Hi everyone, welcome to the chapter 2 of Petroleum Transport and Storage Engineering. In the previous lecture, we generally talked about the petroleum transport and the reasons to transport the oil from one place to another place and where actually the need of transport is required. So now we just have introduction. You can look back and see the introductory lecture wherever the transport is required and what are the modes of transportation available for transporting oil and other products we have. Now we are moving towards the transportation part, and first we have to make sure that what kind of properties are affecting the transportation. For example, you usually hear about the oil tankers, especially in summer, extreme summers, when they go out and they travel from one place to another. Some suddenly they catch the fire, or some suddenly they blast. So why this happens? Well, it's because of its property. Or sometimes when you have a pipeline, especially, and all of a sudden you hear about the blast in the pipeline, and many people loses their lives. So why this actually blast happen in the pipeline? Sometimes when you have the extreme weathers, for example, your weather, uh, each area has its own weather. Their summer is own, their winter is own. For example, in winter, if the temperature goes in sub-zero, sometimes the oil freezes even based on their freezing point. So so in this case, the oil freezes, oil cannot flow. Then again, it's a big problem for us because how we can transport the oil then. So there are so many properties that matters in for the transportation of oil and gas. Without them, if you don't look at the property, you may end up with a big disaster, and it will cost lives as well as loss of money, loss of the economy, loss of the environment at the same time. Therefore, as an engineer, as a petroleum transportation or pipeline engineer or health and safety engineer, we have to ensure that all properties are monitored properly, and all properties are our plants and the pipelines and transports are designed based on those properties. Otherwise, we may face problem and so on. So let's look at it. First of all, look at the crude oil that we have here. You can see these all are the crude oil, but you see the colors are different. So these colors usually depending upon the composition of the oil and so on. No, usually, as you know, that we are interested in a light crude oil, and light crude oil is easy to transport, less energy to move. So we are really okay with this light transportation. Then on the other side, we have heavy crude oil, and heavy crude oil needs huge pumping facilities and more energy to transport, and they create more problems. So therefore, a light crude oil easy to transport, heavy crude oil hard to transport, and so on. Secondly, we have to look at the sulfur content, how much, whether the oil that we are transporting has sulfur or not. If it has sulfur, again, it is toxic. It can take the lives. At the same time, it is corrosive. So we don't want the the sulfur in the crude oil or, or even the natural gas. So, for example, here the sweet, uh, if the sulfur content is less than 0.5 weight%, so we call it a sweet crude oil. But if the intermediate is 0.5 to 1, so this is the intermediate. And if sulfur content is greater than 1%, it is sour or high. Well, there were many the students here, previous students that I have here, they were planning to import the crude oil, but the crude oil had more than 4% of sulfur. Now, this sulfur has to be removed before the processing. Therefore, the price was lower, but at the same time, it has sulfur. It has lots of environmental and health hazards. So it is not recommended to import the oil which has lots of sulfur, because in the long run, it will create a problem for us. Now, first look at the properties. Uh, what kind of properties are there for us that we need to be careful for? First of all, the volume. Okay, then the density. We will talk about them one by one. Then specific gravity and API gravity. Then the viscosity. Then the diluting ratio of hydrocarbons. The vapor pressure. The heat capacity and thermal conductivity. The pour point, cloud point, flash point. All these properties actually matters in the designing of the pipelines, because if you have an improper ratio, improper planning based on these properties, then your pipeline transportation or truck transportation or ship transportation may suffer and create a big issues for us. Then you should know that the oil, we have three different kinds of oil: light, moderate, and heavy. Light is easier to transport, and it does not have lots of heavy hydrocarbons, easy to transport. And heavy hydrocarbon is waxy, has had bitumen, so it's very hard to transport and very low economic value. That's why the heavy hydrocarbons are mostly cheaper, and light hydrocarbons are mostly a bit expensive, and so on. So now let's look at the first part, and let's continue. Well, the most important property, first of all, we need to learn about the volume. For example, now if we have the pipeline, and let's take example of the city of Suleimani, we are living here, and volume, for example, here in July, August, the temperature is around 50 degree, and in winter sometimes the temperature goes to even below zero. So we have fluctuations of the temperature around. Now this is the first thing. Now the volume actually has effect on temperature. If temperature changes, the volume do change. That's the first issue. Second thing, for example, now we have a pipeline from Kurdistan to Turkey. Now this pipeline should have its own design capacity. The design capacity of this pipeline is, let's say, 1 million barrels, 1 million barrels per day. Now, if we volume, if we have to calculate the volume of this pipeline, because the capacity to transport has to be defined when we install the pipeline. For example, now some oil pipeline needs to be less than 1 million. Let's say we want to transport 400,000 barrels per day. This is the our capacity. We want to transport 400,000. So then we will design the pipeline accordingly, and it will be cheaper for us. But for example, now if we want to design the pipeline for 1 million barrels per day, then of course we need a bigger pipeline, with a larger diameter pipeline. And if we want to design with 400 or 300,000 barrels per day, we need a small diameter pipeline. So volume needed to transport has effect on the diameter of the pipeline and so on. At the same time, volume changes because of the temperature effect. And if the volume changes in the pipeline of the oil, then and ultimately changes the pressure of the system. Therefore, we have to be careful for what is the pressure and pressure in the pipeline. And if there are pressure fluctuations because of the volume changes and temperature changes, that we have to consider it. The another property that is needs to be discussed is about the compressibility. Now, what is compressibility? That, for example, if we have this kind of volume, and how much we can be compressed to this one. So how much, if you applied the force on a volume, how much you can shrink it. So in technically or in simple language, we can say that a change in pressure applied to the fluid changes the volume of the fluid. So for example, this is the volume, whatever pressure you apply become this size from V to V1. This is the is compressible. So this fluid, whatever it is quite compressible, because from the large volume it occupies the smaller volume. Now the now in the pipelines or transportation, we are talking about the bulk modulus. Now what is bulk modulus? It is the inverse of permeability and is more frequently used than the compressibility for liquid in pipeline. Now higher the bulk modulus, stiffer is the liquid. Like if more is the bulk modulus, more hard is the crude oil it is. And this bulk modulus is the main cause of pressure surges in the pipeline system. We have to follow the bulk modulus and compressibility, because if they are if compressed, then the pressure is different. But if so, they can cause the pressure surge where the pressures are low, when there is no compression, and it can cause a problem in the pipeline and so on. Look at the, the mercury, and then after that is the crude oil. So higher the bulk modulus, more stiff or more hard the oil is. This is and you can see water 2.15, seawater is 2.34, and so on. Now let's look at the video which is discussing the
solids, liquids, and gases, specifically gases, is a demonstration in air, pressure, air which is a gas. There is gas that remains above the water, filling the space or volume between this red line where the water stops and here where the cap is sealed on the top. This is filled with air, which is a gas. Gases are compressible, more so than liquids and much more so than solids. What I'm going to do next is to tighten this vise, and what's going to happen is the bottle will deform, but also its volume will shrink, the water will creep up past the line, and it will compress the gas towards the top. You see the water level rise past the red line. The shape of the bottle is changing underneath, but while the shape remains the same at the top, it becomes pretty obvious that there is the space that the air had occupied, which is a gas, is being taken up by the water. Now that can only mean that either the gas is mixing with the water, which it is not, or that the gas is being compressed into a smaller space. Its volume is decreasing. That gas is occupying a much smaller space, and without increasing or decreasing the temperature, that can only mean that there must be an increase in pressure. To check for that, I'm going to try to take this cap off. I'm going to try to do it very quickly for a sudden release of pressure. Here we go. The gas pressure demo showing that a decrease in volume causes an increase in pressure. This time I want you to ask yourself, what causes all that liquid water to be ejected from the bottle in the process? Think about that as you're watching it a second time. Here we go.
Now, the another property that matters in the pipeline designing is the thermal expansion. Well, in summer, as I said before, the summer and winter, the temperatures are different. For example, and other that you have a long distance pipeline and different regions have different temperatures at the same time. So because of the temperature rise, the pipeline can expand or the fluids can expand also at the same time. So therefore, it's a function. So we have to be careful for thermal expansion, and I will also show you some videos of how the effect of thermal expansion is going on here. Yes. So thermal expansion actually is not a problem for the heavy hydrocarbon because their bulk modulus is a lot, and they are uh, quite stiffer. But for the light hydrocarbon, it is a problem because when the temperature changes, becomes more hot, the expansion happens because of thermal. At the same time, thermal expansion happens in the pipelines also, and I will show you that how the temperature is affecting the diameter of the pipeline. And if the diameter is changing, again, it has direct effect on the pressure. So I will show you a video which is showing about this effect of thermal expansion on pipelines. Well, this is the temperature gauge and this is the pipeline, and look at the changes occurring here at this point. See, if the temperature is increasing, okay, 50 degrees, look at it how it is behaving, and when at night the temperature is decreasing, how the pipeline is behaving. Just follow it, the changes. Yeah, you can follow the shadow. Look at it here, that it was quite loose, but since the temperature is increasing, see how the diameter is expanding. Fast forward, Now let's look at the other property that we are discussing, which is about the API gravity that we have. When we talk about the specific gravity, it's a relative density, and you can define it as a liquid is the ratio of its density to the density of water at the same pressure and temperature. It is the measurement of how heavy a liquid is compared with water. It is dimensionless as no unit. And this specific gravity changes with pressure and temperature. And API gravity is needed, first of all, because of the pumping station pressure requirement. For example, whatever pump you are installing in at the pipelines, these pumps, if the oil is lighter, easy to transport. But if the oil is heavier, then it is very hard to transport at the same time. So this is the formula to find the API gravity and so on. Therefore, it is needed. And when you do these calculations, because you want to calculate many various other. Yes. So when we are designing the pumping stations, we need to look careful for the API gravity. And there are many other calculations for the pressure requirement, like how much is the pressure needed. So for that, we have to know the API of the crude oil, because API has direct effect on the pressures. And when you calculate the API, you have to make sure that you do it according to the pressure and temperature and so on. Then ahead, these are the API gravities of these products that we have here. The AP light crude oil is above than 31. So if the API is above 31, the pump requirements are different. And if you have heavy crude oil, which is 10 to 22 API, then the requirements are different. So we have to know about the API gravity because of the pressure requirements at the same time. Now we will look at the viscosity, and it's again very important because we are talking about the flow in the pipelines. So, and viscosity is the relative measurement of resistance to flow. So first of all, you have to make sure that your pipeline you are using, it should be a good quality of steel, and it should be polished inside, so that there should be a very less resistance and very less friction for the oil to flow inside it. But this viscosity is actually between the resistance to flow between the molecules of each other. You can define it as the measurement of friction between the layers of flowing fluid. For example, this is the flow of fluid, and at the same time you have another layer of fluid. So when they are moving ahead, they are actually rubbing each other. And I will show you in a video also that this viscosity, if the viscosity is very high, then you need more pumping pressure, you need more energy to transport it, and it will create more increase the operating cost of the product. So I will now show you that how the viscosity is affecting. Okay, when you want to calculate the flow rates in the pipelines, viscosity is one of the parameter or property that you have to care for. Higher the viscosity, and harder to transport and slower to transport. Let's look at a video which is based on actually different kind crude oil with different kind of viscosity, and see that how the viscosity is affecting there is a very important term that we use in oil industry: Newtonian fluids and non-Newtonian fluids. So, but in order to understand the Newtonian fluid and non-Newtonian fluid, we have to first understand what is the shear stress and what is the shear rate. Well, imagine that we have the fluid layers. This is the same fluid we have, and we have two layers of fluid going on. Like we have this kind of thick kind of fluid which is moving from here and there. And when the fluid is flowing, these two are flowing, and so they have the friction between them, which is we call it a viscosity. This frictional force caused by the shear stress between the two adjacent layers. Okay, we call it a shear rate. Yes. So when this move, the velocity of this movement, this layer, in comparison to the velocity of this layer, when we compare the velocity of one layer with another layer, we call it as a shear rate. And the stress is the resistance between both the layers together at the same time. And this stress is the function of pressure, and shear rate is the function of geometry, like how the fluids is behaving, which kind of geometry it is moving ahead in the one. So this shear stress and shear rate actually helps us the we defines the flow behavior of the fluids. That is important here. So if the now let's look at some examples of the shear non-Newtonians and the most. Now, there is one more property that we need to understand is about the pour point. And pour point is the lowest temperature at which the flow will fluid under conditions. Now, for example, if you have the oil and at normal room temperature it is freezing and it's frozen, it cannot move. Then this is then how you can transport it if in the pipeline if it is not flowing. So every oil has its own pour point, has its own pour point, own temperature to flow. And so why we want to know this property. This property actually is more important for, as you can see here, is in the heavy crude oil or waxy crude oil pipeline, because we need more energy and extra care when this and we have to make sure the temperature is above the pour point so the fluid can flow. How we determine the pour point? There is a ASTM method D97, the simple method to know the pour point of the crude oil at the same time. Why we need to know? Because we have to maintain the pipeline above this temperature. If not, then the oil will freeze, and if we keep pumping, keep our pumps keep working on it, then the pressure surge may happen and it can lead to the blast. So we don't want this issue. We want a smooth transportation of oil without any problem. So we have to keep the pipeline above the pour point so that the oil do not freeze and it keeps continue flowing at the same time. Now I will share with you the method ASTM D97 to determine the pour point. Let's look at it how it actually. temperature. I mean, they are freezing at the room temperature. So in this case, we have to make sure that the pipeline we have is above this temperature so that it should not freeze. Now the next property that I want to talk about is vapor pressure. So let's close this part here, and we will continue in the next video about this hydrocarbon problem. Till that time, have a good day and be safe during Corona times.